So we got some cool things that relate to this elasticity business, some shortcuts that are kind of handy when looking at pricing. This is still 6, yep. Just got a few more things to say. So let's just put on here some related shortcuts. Maybe I should put cool shortcuts that we get. That I'm not going to bore you with the mathematics that supports it, but it all ties back to that original formula to give you some cool things. Here's the first cool thing. Marginal revenue is equal to price times 1 over, 1 minus 1 over the absolute value of the elasticity of demand. Now this is weird, so I'll just write it out. And yeah, it's actually math maneuvers to show this, but because you kind of combine formulas. So first of all, remember marginal revenue, the formula we gave you last time was what? Marginal revenue is equal to, I use little triangles.
Oh, change.
Yeah, change in something over the change. Yeah. No. Something over the change. Good. So if quantity goes, or if revenues climb by $100, and that was over 10 units. So 100 divided by 10 is $10 worth of marginal revenue on average for each of those incremental 10 units, right? So that was our kind of bare bones basic formula we did. We even saw that problem that we worked on at the top of the hour. Now that's related in here too. So if I look at a really small change, like from here to here, from this quantity, if I drew this down, you know, if this was 1,000 units, right? So if I find here, this is at 450 to 451, the 450th unit to the 451st unit. What happened to revenue? What happened right here if I get really small?
Oh, yeah.
Did it go down? Stays the same about, right? I mean, I was trying to be right at the tippy point.
Oh, okay,
so that
you said 400 or something. Right?
Yeah, I got kind of just fat markers and everything here, and I meant 400 units. So 450 units to 451 units, or whatever. Whatever. So if I'm right at this point, my point is the change in revenue is basically 0 divided by the change in quantity, which might have been 1 unit or 2 units or whatever units, right? But 0 divided by whatever is 0. So the point is that the revenue generated by an extra unit at this maximum point is nothing. That's how we kind of know that we've reached the maximum, right? So, and then as we continue to move on this way, the revenue generated by these additional units is what? Going back to this part of the formula. Change in total revenue over the change in quantity. If I'm increasing quantity, I went from this unit to this unit, it'd be negative, right? So the revenue went down, so we have a marginal revenue that's now negative. Over here, a price decrease leads to a positive marginal revenue. So revenue is positive. So graphically, we can map in the marginal revenue curve, which I can't remember if I'm giving you a little more information on what this chapter gets into or not, but this seems like the right time since we're bringing up marginal revenue. How does that thing shape out graphically? Well, the marginal revenue curve cuts through that point where the elasticity of demand is unitary. It starts up here, and it looks like this kind of. It actually dips negative. This is like if this graph wasn't here, this line would actually still dip negative, right? Because the revenues are falling at that level. So that's the marginal revenue curve put onto the top graph. And that's kind of the connection. So I wanted to give you that background before we looked at this formula so that you know where we're going at here with the elasticities is, let's do an example. So if the elasticity of demand is 0.81, in fact, this might blow up on us now that I think about it. I think we need, oh no, this will probably work still. I was thinking this might be one of those formulas where we need to be in the elastic range. But anyway, let's give it a try. If the elasticity of demand equals 0.81 and price is, what was our first price with that one? $10. We could do, I suppose we could even do $9, the average. And price is $9. What is marginal revenue? So go ahead and crank that into your calculator. Just plug in these numbers in. As soon as you get an answer, just come under this. How much? Negative 2.11. Yeah? All right. So marginal revenue is negative. In other words, we're operating on this side, which confirms what we had. We were in the inelastic range of the demand curve. We were over here. We got a negative number. So if the elasticity of demand increases for some reason to 2 in absolute value, what is marginal revenue? Given the same starting place with 9. $4.5, $4.50, right? And we are talking marginal revenue, so now this has dollars associated with it. So if demand was elastic and equal to 2, this formula says that the marginal revenue would be $4.50. All right. It can tell us on what to do on marginal cost of these units is 2. Should we lower our price? Is our price too high or too low? Too low. Good. Yeah. So if we go back to our graph that we did, marginal cost, marginal revenue, and marginal revenue, by the way, isn't, let me go back to the fancier one. That's what's kind of nice about this formula. The marginal revenue function might look like what we just drew over here. If marginal revenue is higher than marginal cost, then we know we're not at the optimal point of where marginal revenue equals marginal cost. And so in order to sell more, drop price. And that'll be profitable. It'll sound a little scary maybe at first, but we're not at the right price that maximizes profits. So it's kind of bringing us back to our original intent in the first place. Okay. Let's jump into other types of elasticities. So this whole time we've spent on the price elasticity of demand. Turns out you can calculate an elasticity for anything. So we talked about bowling shoes and bowling games, the number of games sold. So we can calculate an elasticity called a cross price elasticity if there's a decrease in the price of bowling shoes of 10%, how many more bowling games will I sell? Right? The formula is going to look suspiciously close to what we did before. So across price elasticity, which I'll just use the shorthand notation here of sigma with a CP. The cross price elasticity is equal to the percentage change in quantity sold divided by the percentage change in the price of a related good. Let's just put RG subscript. So the percentage change in quantity that comes about from a related good changing. Again, if I eliminate this RG, whoop, price elasticity, cross price elasticity, price elasticity, cross price elasticity, right? So same formula, same concept. I'm not even going to bore you with the rest of the math at all. As before, except now we're thinking about the related goods as opposed to the price of the same good. Yeah, related good. Related as complements, good, or substitutes, right. Now, sometimes we don't necessarily know maybe what we're getting into. Like our gut tells us that the world should work a certain way, but we don't know for sure. And so what economists do is they gather data and test that. So if we learned that suppose, do a little example. Suppose that the cross-price elasticity of beer and wine was found to be 1.4. Are they substitutes or complements? So let's say that we've got beer up here, quantity of beer sold, price of. If the elasticity turned out to be 1.4, are they complements or substitutes? Complements?
Yeah.
So why do you say that? What's your interpretation?
The elasticity is higher than 1.
Okay, it's higher than 1.
Meaning they are.
So go back to that interpretation. But now you got to put the right things in the right place now. Which one gets the 1? Remember we did our little trick here of 1.4 over 1.
So elasticity is over 1, it's a complement.
Well, that's what I want to see, if that's true or not. So instead of memorizing it, I want to see what we got here. So interpret this 1.4 similar to the way we did it before. Just tell me the story.
1% increase in the wine.
Okay, 1% increase in the price of wine, great. Leads to?
To a 1.4 decrease.
And why did you get the decrease?
Should be negative.
Should it be negative? So,
Well, if it's constant, I understand we talk about it as negative.
yeah. So we don't have that going on here. In fact, when I gave you the interpretation, before, for the regular elasticity, I didn't have the bars on it, right? Remember, because it was 0.81, and that was over 1, so we said a 1% increase in price leads to a 0.81% decrease because of the negative sign. We don't have that here. So how would you interpret that? You're doing great. A 1% increase in the price of wine leads to a... That's the case. If the price of wine gets more expensive, a 1% increase in price of wine leads to a 1.4% increase in beer. Are they substitutes or complements? Substitutes. One goes up and the other goes up. So they're moving in the same direction. So if we had this relationship, they would be substitutes because an increase in the price of wine leads to a increase in the price or in the quantity of beer. Well, that's you got to be. Nature's going on, the economy's going on. We look at the data, and it is what it is. So I'm not going to make them, but rather, how could we have found that? Would be if we would have happened to do a different study or a different time or different goods, and that was negative. Yeah. Now we got exactly what you're saying. A 1% increase in the price of wine would lead to a 1.4% decrease in the quantity of beer, right? And then we would have dubbed them complements if that was the case. So this is the cross-price elasticity of beer with respect to wine. So if we did it vice versa, by the way, we should find similar results, but we'd have the good in question is beer. You're kind of making me get let me do one thing here and then I want to come back to you because I want to show you something else. So substitutes because of this. So therefore is if the cross-price elasticity, no absolute value business, is substitutes, then the goods are substitutes. If the cross-price elasticity is less than 0, then the goods are complements. And then I don't want to ignore the last possibility, just to complete the set here. If the cross-price elasticity is equal to 0, then the goods are so 0 is kind of our anchoring point. If the cross-price elasticity is equal to 0, not the same, but I think you're on the right track. How are the goods related to each other?
Unrelated?
Unrelated, good, right? So you can change the price of wine all you want. It's not gonna affect my beer purchases. So then they're actually unrelated. Are unrelated. That's important as we get into the estimation business too, is that we might find some goods that don't. All right. So this isn't even too big a time, but let me just sneak this in here. What does I'll get real fancy on here, the multivariate demand curve look like? So multivariable, what does it look like? Well, quantity demanded of, let's go ahead with beer, is equal to the variables that we think are important on determining our quantities of beer, which we've already talked about. So I'm just laying it out different for you here. The quantity of beer we have already learned is a function of the price of beer. We've also just determined it might be important the price of wine. And it also might be important what our income is. And maybe it's our gender on whether we're males or females. Maybe males tend to buy more beer than females. I don't know, but that'd be an interesting thing to include in on a study, right? Because then we might be able to target our advertising. Do we make it more attractive for the gender that is the dominant purchaser, or do we maybe do a different marketing campaign where we want to attract the gender that doesn't seem to be buying our product? Maybe that's more important to spend advertising dollars on. And dot, dot, dot. Maybe there's some other things too. So let's just put a few dots in there. Now there is some crazy function that might describe how important each one of these variables are. So, which ultimately ties back to the elasticities. If we say the number of units of beer is a function of the price, and we put in the price of beer equals to 100, well, we could have a equation that describes the relationship of all these things. And economists indeed do try to estimate that. That's what the real demand curve is. So that gets to a level of detail we're not going to do in this class, but that is the demand curve. And the reason it popped in my mind when you said over here, I can't exactly remember why that popped into my mind. What was your question again?
Well, I was asking why you would choose the beer to be the quantity.
Oh, yeah, right. So in this case, the cross-price elasticity is thought of to be the cross-price elasticity of beer. That's the variable of interest. That's the dependent variable in this equation. That's our the thing we're trying to determine.
We know that because it's mentioned first in the problem.
Yeah, probably. Yeah, I suppose the cross-price elasticity of beer. Yes, that's right. Yeah, so the beer would be the one on top, the way it's worded there. But more fundamentally, this is what we're thinking about is how much beer are we going to sell? Well, that depends on, in Ottawa, we have 61% male and 39% female. Does that make a difference as opposed to Olathe that has 55% male and 45%? You see what I mean? So we can take this analysis and we can look at how sensitive these variables are maybe in a particular community. If we're estimating the demand for beer in Ottawa, it's a function of price. Ottawa is one of the lower incomes counties in the state of Kansas. I don't know if you know that, but it is. That's why things are kind of cheap around here, which I like. But we have a lot of lower income people on average. And so that tends to drag down, maybe this is a bad example, that might be inversely related here, but that's what we do the data analysis for. So we can find these relationships. Okay, so I wanted to insert that here because now we can find the elasticity with any of these things, even gender perhaps. So the elasticity, the next one though that I want to officially mention is the income elasticity, which is a number that shows the relationship of quantity sold to percentage changes in income. So if the economy of Ottawa is experiencing expansion due to a new industrial park that they put in, which is all, by the way, a true story. There's a new industrial park down by the Hardys off the freeway that they're hoping will lead to prosperity. Maybe this new school, $63 million worth of money being pumped into the infrastructure for the schools. Maybe young families will start to find Ottawa a little more attractive. Ottawa starts growing in population, growing in on income per average. As the income goes up, what happens to the quantity of beer sold. Now we can also look at the quantity of peanut butter sold and other things, right? And so all of those are going to have varying impacts, but our variable that we're measuring is the income. Maybe it's the median income for Franklin County. Or maybe better yet, we've surveyed 1,000 of the 13,000 residents of Ottawa, and we've gathered data on what their incomes are. And then we can put that into a computer program and crank out some numbers that are going to show these elasticities. That's where these elasticities come from, is from real-world studies. You'll see that in the chapter when you get to it, of numbers that they'll show you for real examples of what these elasticities are. Okay, so if the income elasticity is greater than 0, i.e. a positive number, if the income elasticity is greater than 0, then the good is blank. What type of good is it if the income elasticity is greater than 0? It's a positive number. Income goes up, we sell more. Which one was that? Income goes up, we sell more. Income goes down, by the way, we sell less. So there's a positive relationship between the two variables. Income goes up. It's in your notes from an hour and a half ago. Normal, good. So if the income elasticity is greater than 0, that good is a normal good. Now we're tying it right back to those demand shifters that we started off with at the beginning of the hour. If it's less than 0, we have one of those ramen noodle goods. What did we call those? Inferior good. Okay. So advertising is another thing, changing taste or preferences. So businesses can calculate these elasticities for just about anything. We can start to think about the effectiveness of some of those tools. All right, so let's see. The last thing I'm going to mention from Chapter 6, there's a few things I'm letting you do on your own. Not many, but is the stay even analysis. Stay even analysis. So the question it's addressing is, how many units do I need to sell at a new price to stay at the same profit level? All right, so again, this kind of ties in our profit decision of marginal revenue equal marginal cost. So Q1 is equal to the initial quantity times the ratio of the new price, the old price minus the old variable cost, divided by the new price minus the old variable cost. Again, there's kind of some math and formulas that show how this would tie back to marginal revenue equal marginal cost. And it's kind of a nice hypothetical to see whether it's realistic or not, the price change that we're looking at. All right, so the nice thing about this is that we know, whoops, this is the company, when we put the, sometimes economists stay a little too abstract in terms of what we can and can't do. And so what's nice about this is the company, if we go to Pepsi again, we know this right now. What's our initial quantities we're selling? Like what have we been selling now the last month? And we also know the price that we were selling them at, our current price. So we know our current quantity and our current price, but sometimes that's all we know if we're running a business for a while. We might have gathered some data on previous stuff. We also know our variable cost. And then this is the hypothetical change. This is the hypothetical change. If we made it $10, if we made it $12, if we made it $13. That's the one in the boardroom with the other executives were saying, hey, should we raise tuition to this? What would be the impact? And again, what we're looking at it being an impact on is the number of units we would need to sell to maintain profitability. So if the new price is higher, the quantity demanded is going to fall. If we're raising the price, the quantity demanded is going to fall. What quantity would need to occur to stay even? So this isn't the quantity that we may get, but rather it's the quantity that keeps us even. Okay, that's a little bit slippery. So remember, I mean, the definition says it up here, but that is the quantity that keeps us even. Not the, and let me just emphasize that, not the quantity we will sell. Not the quantity we will sell. That we'd have to get back to some elasticities. Boss says we would still need to sell this amount of units to make this formula happen. And they're like, well, we're going to do that for sure. Let's do it, right? So I think we're going to actually make money on that because I think that quantity is going to be even bigger. And so this is the quantity that keeps profitability even. And maybe that change will be better or worse, but at least gives us the number that cranks out the math that tells us that we'll keep it even. I will leave it there for chapter 6. I found that the stay even one's a little hard to read through. Hopefully now that I've given you a little bit of that background, once you come back to it and read it, it'll make more sense too. All right. So let's I'll attempt to disconnect this. Do a little more PowerPoint action for chapter 7. Get into some examples and stuff. Since we had some amount of time at the board. See, I don't like the lighting.